Hi everyone, how are you? Redfern here once again. So this video is to explain what the difference between a IPv4 and an IPv6. So before I get into what the difference is, I'm going to give you a little bit of a history lesson behind the IPv4 so you get a good understanding of what it actually means to you as a consumer. Now, for those of you that aren't very techie, a lot of this won't make any sense. But for those of you who do understand the internet and do understand computers, it's some pretty interesting stuff. So the short answer to the question is, what is an IPv4? This is the fourth version of the Internet Protocol, your IP address. And it is the Internet Principle set of rules for communication. It's put in place around about 35 years ago by the US Department of Defense, firstly to deploy on its ARPANET, Advanced Research Protocol Agency network in 1983. The Internet Protocol version 4 is also a crossroads. It is a global IP address supply that is now nearly exhausted. The internet is undergoing a gradual transition to the next version, which is the IPv6, but not without a lot of challenges, and I'll go into that in a little while. In this explanation, we're going to cover what the IPv4 is and how we will be then moving over to the next stage of the IPv6. So before we get into the IPv4, a little more interest and information about how the internet works. Okay, so an IP address is part of an internet protocol suite, which also includes a transmission control protocol. Together, these two are known as the TCP and IP. These two together are everything to do with you and the device that you are using. Then this information gets sent over the internet. It is the package governing rules for addresses, transmitting of information, routing and receiving data over the network. An IP address is a logical means of assigning addresses to a device on the network. Each device connected to the internet requires an IP address. Most networks that handle internet traffic are package switched, which means small units of data called packets are routed through a network, a source host like your computer that delivers this IP packet to a destination host, which is a server based on an IP address in packet headers. Packet switches allow many users on a network to share the same data path. An IP address has two parts. One part identifies the host, which is your computer or other device that is connected to the internet, and the other part identifies the network it belongs to. The TCP/IP uses a subnet mask to separate them. So how does a DNS fit into it, and what is a DNS? A DNS is a domain name server or domain name system. It is the phone book of the internet. It translates domain names that we easily remember, i.e. redfern.com for instance, into an IP address like 4 blocks of numbers, so 104, 239, 971, 100 for instance, which is the language of the internet. A DNS allows computers, servers and other network devices with each of their unique IP addresses to talk each other, and it gets used to these websites they are looking for. Okay, this is why when you go onto Google and you are searching for a name, that pops up quicker because computers get used to what people are searching for. So now exactly what is an IPv4? The IPv4 is the fourth generation of an internet provider, an internet protocol device. It is a 32-bit integrated system that can be expressed in hexadecimal notation. What does that mean in layman's term? It basically means x.x.x.x. So you can have anything within those x's of 0 to 255. For example, 192.0.2.146, for instance, is a recognized IPv4 provider address. The IPv4 still routes most of today's internet traffic, but like I said, it is nearly full. A 32-bit address space limits the number of unique hosts to only 232 per IP address, which is nearly 4.3 billion IPv addresses for the world to use. And that is, in nowadays, running out pretty quickly. So today we've run out. Think about it. How many connected devices are in your household? For instance, 2 of us at the moment have 5 different devices that need to connect to the internet. And this is without gaming consoles or printers or anything else like that, which all then do add up to a lot of IP addresses. So it's saying here actually the average American household has 5 devices, including smartphones, computers, laptops, tablets, and streaming media devices. That means even including the range of devices that fall under the Internet of Things in this category, such as connection thermostats, smart speakers, and doorbells. These all need to have IP addresses because they go through the internet. So in today's world, an ultra connection computer networks, there were stationary and mobile devices that need these IP addresses. It turns out that 4.3 billion just really isn't enough, is it? So we need to come up with something else. And this is where the new version of the IPv is coming in, which is going to be called IPv6. So before I get into this, why do we need IPv6? Quite frankly, it is because things are getting upgraded. Like I said, IPv4 has been around for a long time. We need to upgrade the speed of the IP addresses, so IPv6 has been developed. So this is the latest version of the Internet Protocol. It addresses the 32 bits to a 128-bit address space with both letters and numerals to identify it. For example, you could have 2002 DB8, another set, okay, within these 4 blocks, so you can have a much more bigger variety of everything that is out there. You also, on top of this, is the version of the IP has some obvious advantages. The primary one being that it has a lot more space. With an IPv6, a single network can have more than the IPv addresses for the entire of the IPv addresses in one of those squares of the 1P4s. For example, you can put enough IPv4s and IPv6 are not directly interchangeable. IPv6 is not the easiest protocol to walk into, and that is because the platform that the IPv4 runs on, that 32-bit, takes a lot of work to get it up to the 128-bit of a IPv6, because it's a big undertaking and challenges for people who have already had that. So in short, with us, and this we are talking about ONPASSIVE now, because we are starting at scratch with an IPv6 Internet Protocol version. This means that we are set to go on this 128-bit protocol, and everything will work from that. We don't have to worry about the old IPv4 at 32-bit because we are starting with our data center at 128-bit. This is going to be a massive game changer for a lot of companies out there, because if they're already set up on an IPv4 with their existing servers, they can access the IPv6 very easily and quickly by transferring all of their data over to our own data centers. So that's it from me. Thank you very much for listening and watching this explanation of the difference between an IPv4 and IPv6. This is the first time on my internet channel. Just down here is the subscription bar. Give that a quick like, and also make sure you hit that bell next to it, and then you'll be notified whenever I put up any more videos. Anyway, that's it for me. Bye for now.